So before we get started with this, I know I've started sharing this already, but we have an exam coming up on Friday. So it is on paper in person. So anyone who is remote will need to either find their way to campus or arrange something with me so that you can get access to that exam. I know that we have some people remoting in from Cheney's campus and may not be as easily accessible to come into class. So if that's the case for you, please send me an email. I'd be happy to arrange something with you, but just make sure you do it in advance. Don't let it just slide past the exam date and not show up for it, because that will be bad. The study guide is out though. Did anyone have any questions about anything on the study guide that I can address before we start talking about what makes your code stanky?
Will there be any, like, we have to write out a test on the?
Possibly, yeah, you will need to know the syntax for things, so have a little bit of practice with writing out tests.
Are you still allowed to have like a note card?
Yes, you are all allowed a 3x5 note card. It can have anything on it. I'm not gonna check it. I'm not gonna collect it after the exam. So make sure that you have that with you. That will be very useful for anything that might be memorization or regurgitation. I'm not a fan of that in general. I'm not just gonna ask you, what is the definition for this? And expect you to regurgitate the exact definition on the slide. I'm not that kind of person. I more so will design questions that are application based, take an idea from the slides and then say, construct a test that is a well-formed test that actually looks at, if here's the problem, write the tests for it. Something that has you thinking critically, applying the information that we've learned, not just regurgitating it. That won't necessarily be all of the questions, since I may need to hit 8 or 10 different ideas in the exam. There's only 50 minutes. So maybe some of them have to be some shorter, slightly regurgitation type questions, just so that I hit a particular learning outcome on the exam. But wherever possible, I will have you solving a problem, using critical thinking, writing tests, determining what tests need to be written for something like that. For something like the unit tests, I will probably give you the list of assertions, the assertion functions. So you don't need to memorize those. You don't need to put them on your note card. They should be on the exam, because that's an unnecessary thing to memorize. You could Google it and in 2 seconds, you'd have the list of possible functions. I don't want to test you on whether or not you can memorize something that you can Google in 2 seconds. Other questions about the exam format, anything on the study guide before we hop into code spells? All right. So as mentioned, I guess I kind of want to preface this entire lecture and most of the rest of the material in this class with, it's going to be very high level, very abstract. So it's not as easy to make thrilling as some of the material that we've covered to date. So some of this is going to seem very, I don't even know how I want to say it. It's gonna come across like it's just a bunch of information overload. I'll do what I can to kind of take a step back and make this slower, but recognize that you will need to make the conscious decision to pay attention through something that might be a little bit difficult to pay attention through, just because of the nature of this content. So I'll give that as a preface to this. So we'll start with some motivation, as I always like to do. You can imagine yourself in the following situation. It's the night that a programming assignment is due, and you've been working on it for hours. You finally have everything working according to the specification. It may not be the prettiest thing you've ever produced, but great, everything is working. The process of getting it to that point wasn't particularly pretty though. So you take some code shortcuts. You don't want to go back and make your code perfect because you might accidentally break something. It's right before the deadline. You don't want to go change your code, make it extendable, something that a future employer would actually want to look at. At this point, the lab's done, you're ready to just submit it. Does it sound like something that people have experienced at some point in a prior class? It definitely rings a bell for me. That is how I used to program when something was due. So I write this as something like, this sounds familiar to me. So it probably sounds familiar to some of you. Even if you don't want to admit it, it's probably happened. So code smells in general are just ways that your code can start to be less extendable, less readable, it's the kinds of shortcuts that you might want to make to just make something work. And if you take a step back from it and analyze the design of it, you go, wait, this is suboptimal. This is not my finest work. So let's highlight some of those things and talk about what we can do and what benefits we gain from making these associated changes. So the goal of this entire unit, and in fact, the rest of this course, is going to be learning to recognize and fixing common issues in code. There are going to be some basic OO concepts, which are what the code smells are going to be, and there are going to be more complex problems where we're going to use design patterns to solve those kinds of problems in ways that don't produce code smells. So we'll be referencing back to these code smells when we start talking about design patterns, because they are more complicated general solutions to common problems found in object-oriented programming. There are multiple categories of code smells. They are in 5 broad categories, and we're going to go over each of the categories and each of the possible smells in each of those categories. First category is bloat. So as you continue to go back and change code and change code and change code, it becomes really difficult to work with and understand, especially in a larger project where you might have some code that you put there that was required to make it work last time, but ends up no longer being needed after you go back and implement some more stuff. So being able to recognize kind of some unnecessarily bloated code and what you can do about it. OO abuse. This is what happens when you incorrectly utilize object-oriented principles. Change prevention. These kinds of things prevent you from going back to your code and producing more code that is aligned with it. Whenever it's possible, we want to program in a way that is general, that allows us to be able to go back and use the prior code that we've written for projects that are larger in scope. So these kinds of code stink make it hard or impossible for you to go back and extend your code. Dispensables are completely pointless code. You can just straight up delete it and it does not affect your output at all. So you can either just straight up delete it, or with some potential refactoring, you can move it to somewhere else in a simpler form and then delete it. Finally, we have couplers. This means that you have 2 classes that work way too closely together. They know way too much about each other, and they're very interrelated. A change to one class is going to require you to make changes to the other class. So now we're going to go through, it's probably about 4 to 6 different smells for each one of these categories. So there are quite a few of them to go through. Some of them are straightforward and you will have seen them in your own coding, and some of them will be kind of advanced. And for these, I will often reference an external site. And in fact, this is an external site that all of you should be referencing as you develop code and as you, especially for this class, because it contains almost all of the information that we will go over for the rest of the course. So the site is Refactoring Guru. Has anyone heard of the site Refactoring Guru before? I'll reference it throughout this slide deck, but it contains a bunch of tools for refactoring your code. It contains references to every one of these code smells and references to every one of the design patterns that we will talk about for the remainder of the course, as well as some design patterns that we will not have time to cover. So if you're ever looking for an external resource, it is a phenomenal all-in-one external resource for everything that we will do in this course. So long methods. Number one, long methods. So what do we think? Before I even go into this, what do we think it's going to be about? What is the issue with long methods?
Usually be broken down into small methods.
Yeah, a general rule of thumb, yeah.
Oh, I was gonna say, like, maybe an example would be a bunch of if else statements where you could instead switch it to a switch.
A switch instead of if else, or yeah, usually breaking down long methods into multiple smaller methods that do less stuff. The general rule of thumb, and this is a very abstract rule of thumb, is something like if the method is longer than what you can see on your screen, then it is too long. You should be able to digest an entire method in one. You should not need to do any scrolling. If you find yourself writing a method that's longer than the screen, you should really start to think about, do I need all of this in one method, or can I break some of this out into some other methods? So one thing that I find that a lot of novice programmers do, as you go back to add some additional functionality to something, you go back and you extend existing methods rather than make new methods for that use the existing methods. So one thing you can do about that is to make new ones. So eventually methods don't just do whatever their name implies, but maybe they have some sequence of tasks that they do that end up not really being related, or especially related to the name of the method. It's just kind of shoved into one long method that does some very abstract thing or 4 or 5 concrete things. If you have a really long method, it's really hard to reuse it. So if you're designing a program in a way that you have, one way I like to think of methods is we have a large method that does a lot, but it breaks it down, and for the first 2/3 of it, it calls another method and gets back that result, and then utilizes that to calculate something else. And maybe there's another smaller method in here, and maybe this method calls another method for the second half of this. And so this entire process where time is running down this way, you call this method, which calls this method, which calls this method, which returns and passes that, and returns and passes that back, but this method calls that method. So you start to see how the code functions as time progresses. The issue is, if you have this method that embeds all of this logic inside of it, what happens if you only want to do that much work? So we only want to do this work and not this work. Or vice versa, we only want to do this work, but not this work. You can see how this method is so long and convoluted that we can't break it apart into its different pieces without making our code, without duplicating code. You have to rewrite part of this as its own separate method. But then you have code duplication, right? You've just taken this code and you've duplicated it over here. Does that make sense? We don't want code duplication because this is long code that is part of this whole process. What can we do about this? How could we easily fix this problem?
Make that code we need, the duplicated code into its own method,
Yeah,
and then use that method in the next thing.
yeah. So we turn this into 2 separate methods where we have something where this represents this and this represents this. And we just split apart this big method where this had to be coupled together. If we call this code segment A and this code segment B, we have a method right now that does all of the logic in AB, when we really want to separate the logic out into A is its own separate thing and B is its own separate thing. And this means that we can call A and B separately and do something like call A and then call A again. We could not do that with this code because this method was too long. Does that make sense? Long methods are bad for code extension or code reuse because you have an entire process that is constrained to work on its own. When you want to split this apart into all of its components, then you can rearrange those components as needed to produce other code or something that is extendable and does other things. So whenever possible, small methods are best. So things you can do. And another way to recognize that your code is too long, if you need to comment on something inside of a method to communicate to yourself or someone who's using your code what your method actually does, then it's too long. It's too complicated. You should split it into other methods. Between the name and the java.comment that's on the top, you should be able to explain at a high level what every method in your code does. As soon as you need to put inline comments that says what this particular loop, inside of this if statement does, that's all in one method, then you've made a method that is too complicated. If you have a descriptive name for your method, then you don't necessarily need to describe what's going on via a comment. But you should be able to, in one sentence, describe what a method does. If you need more than one sentence to describe what a method does, break it into more methods. Some additional design tips. If you have reliance on local variables inside of a method that returns a value and you need access to that variable later, you can factor that out. If you have a really long conditional statement, that can turn into a Boolean method that returns either true or false. Since any if statement resolves to true or false, you can break any if statement out of a method and make it its own method that returns a Boolean. Do both of those design tips make sense? Again, there's going to be a lot of these. So my recommendation is either making notes, go back to these slides as we go over them, because these will come up again and again as we talk about design patterns and good OO code. Large classes is the next kind of bloat we might talk about. So long classes. Your class may contain a bunch of fields, a bunch of methods, or really long code. If that's the case, then it may be time to reconsider if this class is actually multiple classes. When you design classes for the first time, they'll start out relatively small. But again, with refactoring over time, as more and more requirements come in, you will try to add functionality to existing classes rather than try to refactor and figure out what portions of these existing classes and these new requirements belong in their own separate classes. The easy solution is just build it into the existing structures. But then the structures start to lose what they're actually about, because there's some conglomeration of ideas, and a class should be a very simple object. So it can definitely seem like less work or less daunting to put new features in existing classes, but it creates this issue over time. When you go back to this and try to refactor it or try to do things like, you'll find that you end up needing to duplicate code across classes. You will find that you need to duplicate functionality because it's baked into a class that does something else. And it's hard to separate that at that point from the behavior that's not related to the object as much anymore and the behavior that is related to the object. That's kind of an abstract idea. We'll see a lot of abstract ideas in here, but how are we doing so far? Do people see this? Is this okay? Do you feel like you see the use of doing this, or see how it can go wrong, or all of the work that could go into it? I guess that's what I'm trying to disseminate here, is how much future work this can cause if you take these kinds of shortcuts in the short term. The night before something is due, Sure, get it working, get it turned in, but before you show it to anybody, make sure that you go back and make it pretty. So some design tips for large classes. If you have some kind of feature in a class that is large and you can kind of factor that out into its own object, it's often worth doing that work to make sure that you have more classes that are smaller rather than fewer classes that are larger. Again, that's just in general. There will be times where that does not make sense. There's a feature of a large class that can be implemented in one of a bunch of different ways. You only use it in rare cases. Rather than trying to fit all of that into a single class, you can use an inheritance hierarchy where you have subclasses that represent that behavior and the different ways that that behavior can be instantiated. We'll actually talk about this as a design pattern because this is so commonly seen. But you can use inheritance and make some number of subclasses that represent that behavior. And that will be significantly better than trying to bake all of that behavior into a single class. Another piece of bloat, primitive obsession. Who loves primitive variables as much as I do? Ints, doubles, characters, they're just so exciting. If you are using primitives in too many places, then you might not get the level of features support that you would want, or it will make your code more complex over time. So if you have very small objects that maybe just have a field and maybe a single method attached to them, it can be difficult to justify trying to make a class out of that. But it's absolutely worth doing. So one example of this is currency. Has anyone written a program where they represent dollars as just a double? Yeah, I've done it too. What are the pros and cons of using currency as a double versus making a class? How would you design a class to represent some amount of money?
You have dollars and cents, like a formatting.
Yeah, you could have integers for dollars and cents, and then a two-string method that prints out the $sign, the integer for the dollars, a period, and the integer for the number of cents. Does that make more sense than using it as just a primitive? What does that allow you to be able to do? You could even use a double for the whole thing. You just want to, maybe for the two-string, tack on a $sign. And then from the end user's perspective, they never have to worry about adding that $sign ahead of the currency. Another example for this is a range. You could easily place a lower bound and an upper bound in a range. And then for a two-string, print out something like left square bracket, lower value, dash, upper value, right square bracket, and that would get you the associated range for something. It's really tempting to just store this as local variables, as primitives, int lower value, int upper value. You can easily make a very small class that doesn't do very much that represents a range that allows you to do exactly the same thing. Another example is a phone number. You could store a phone number as a 7-digit integer, but then printing out that phone number becomes a little bit difficult. It would be nice to just have a two-string method that converts the 7-digit phone number or the 10-digit phone number into an associated string that is nice and easy to represent. Some of these side effects, if you try to do this with things like doubles. Are we familiar with floating point arithmetic errors? Have we seen this before? You add double D equals 2, double D2 equals 1, and then you try to add D plus D2 and you get something like 2.99999999998. So if you use primitives, you can get the associated arithmetic errors that you might get with those. If you break down things like division, you can get division by zero errors. If you break those into their components, you can add logic as methods into that to be able to check for things like division by zero, to be able to check for things like floating point errors. You can add logic to your classes. You'll find that some potentially impossible values for something are possible. So if you put this in a class, you can add logic that says something like, all right, if we have an amount of money, it can't be negative. A double, on the other hand, can be negative. So you have to test the value of the double wherever the double is used to make sure it's not out of bounds. On the other hand, you can add that logic and those kinds of tests to your class to make sure that at the end of every operation with this object, it is a legal value or a possible value. You also, if you use primitives, it can't be extended without a later refactoring of it into an object. So if you already have it in object form, it just becomes easier to add to that class or turn it into an inheritance hierarchy or something of the sort without actually thinking about, is this needed in the future? One thing that can also be considered primitive obsession is if you overuse static class constants. So if you find yourself writing a program and you have static final int something equals this, static final something equals that, and continue that process, and you have like 5 or more of them, maybe it needs to be in an enum. Maybe it needs to be its own object type that can be in one of many different states. And then you get the associated functionality that you get with an enum, or that you get with an object, or the extendability that you can get with an object. Questions about overuse of primitives? All right, long parameter lists. Who's written one of these? Some kind of constructor that takes 10 inputs, or a function that just takes a bunch of inputs? You try calling one of these things, and it is such a pain to figure out what is the associated order of the parameters. What do they all represent? So this occurs if something, some object, some constructor needs a bunch of information in order to be able to construct the object or in order to be able to calculate what you need to be able to calculate. So the question is, what can you do about this? When you find yourself wanting to do this, what can we do? So as objects get more and more functionality, we start needing more and more information to be able to construct them, or more and more information to be able to do anything to them. Any of the behavior, any of the methods that are associated with the object. Why is it an issue? Well, let's ask that. Why is it an issue? I mentioned a couple of things, but does anyone else have anything to add to that in terms of issues that it can generate? It's a pain to call.
If someone else has to like modify your code, they have to figure out what is going on.
Yeah. You're assuming with this that you're the only person touching this code. If you're in a large design team and someone else has to figure out what is this object doing? Oh gosh, why does it have 10 parameters? It happens. Like this exists, and I'm talking about it because it's very easy to get yourself in this position. I find myself in this position a lot. Just having some alarm that goes off in your head when you recognize this will allow you to be able to look up some design tips for how you might avoid it. So step number 1 is just being able to recognize the code spell. You see a parameter list that is long. I want you to know that there's something you can do about it. So finding yourself passing multiple pieces of data from a single object. So like, let's say we have a person object and some calculating their where to route and send their paycheck will require that person's bank account and that person's salary and that person's number of hours worked and that person's, all of those will be embedded in the person object. So you can imagine your parameter list being, if we had a person object called P, P dot get this, P dot get that, P dot something else. If all of your objects, or many of them, are coming from the same object, pass the entire object via shallow copy or by reference. I mean, the same thing. So you're just going to, in some scope, somewhere, you have a person object that we're going to call P that has a bunch of pieces. And rather than passing this piece over and this piece over and this piece over and this piece over, we're going to say just pass a reference to this object so that this scope can see it from here. We're going to create another name for this, call it whatever you want. Payee. The person getting paid for their labor. And it represents this person object. And now we only have a single parameter being passed to this scope from this scope, rather than every part of this individual object. And then in the logic, in the constructor or in the method, you will have access to all of these getter methods, but you don't need to pass the value in a long parameter chain. Does that make sense?
I don't quite get that.
Yeah, so
Do you still pass it in the, where you put the parameters?
yeah, so let's say we're trying to construct this object, this payee object, that's gonna involve all of the bank information for paying this person. So that requires, we'll call it 7 pieces of information. So we could have it's variable. Now we could either, this is going to be a payee object that's going to be called worker, why not? And we're going to construct this payee based off of all of the elements of this person P in another scope. So the bad way to do this is to do something like, and then of course, we're basing this off of some person object. So we'd have something like P dot get hours. And continuing down here, P dot get, what else is relevant? Salary. And eventually we can close this as the constructor is complete. So this is a long parameter list of all of the pieces of this person's object that we all need to be able to calculate how much money and where to send it. I'm coming up with this example off the top of my head, so I apologize if it's not the best example. But the idea is if we just pass, instead of P dots this, P dot that, they're all elements of this person object. So we can replace all of these calls, all of these elements of our constructor with just P as this object. And then inside of the constructor for this, the actual logic will have the P dot something. And you can access the elements of this. And that allows you to basically copy this object without copying each of the fields. You're making a reference to it. We talked before about the concept of shallow copy, where we have 2 different names for the same object. Here we would have 2 different names for the same object. We're making a new name for this object, and we're going to reference it here. We're referencing the same field, the same information, without having to copy over every little piece of it.
Isn't this kind of equivalent if you just make this to the person as a class and the payee as a different class, and you put the person class into payee class, so you can just associate with that instead of
Yes,
making a constructor?
yes, that would be ideal as well, but we'd still need to figure out which person are we talking about. If we had a variable that was a person object in here, we'd still need to make the link of who is that person object when we construct a payee object. But yeah, exactly, you'd want to use some kind of composition or some kind of OO feature here. But if you're using a long parameter list and you find yourself find a lot of that coming from the same object, we can just pass the object and then access the public getter methods from that object whenever we need to do the associated logic. And that factors it out of every time you make a new payee needing to get all of those pieces of information. You write this code once, you can make any number of payees with a single call with a single parameter. It makes less work for the person who's using this code. And then all of the associated code for this goes in here, which you only write once. Rather than every time you make a new object needing to isolate and find all 10 pieces of information or all 7 pieces of information. Excellent questions. Are there any more? Really thrilling stuff, I know. One other place this could come from is if you have multiple parameters from different objects, but are passed together in a coupled way. So for instance, we have class A over here. We have class B over here. And whenever we run this particular method over here in class C, we need to get something here from A, and that's a parameter, something from B, that's a parameter, some other thing from A, that's another parameter, some other thing from B, that's another parameter. And these are always being passed together. Not necessarily all from the same object, so it's worth copying the object by reference, but they come from different objects and they're all used together. Then instead, we can make an object that is a parameter object that says we can construct this particular parameter object out of these pieces of information. And then you can pass this object by reference into that object, if that makes sense. So you make an object of type these particular pieces of information, and then you pass a single object of that type. So it makes it a single parameter, and then you can factor out the code to make one of these objects into some other part of the code. It's a lot of arrows. I'm not proud of that. I think I need to refactor my arrows.
If you're always using the same stuff, like say from NP, you're only using the same stuff with A and B. Could you get that stuff in the constructor of B, and then just pass B, once it had all that stuff from A?
Potentially, but if B is never going to use those things, then every time you construct a B, even if you're not doing that, you need those pieces of information from A, and that feels bad.
Yeah.
That's a good idea, for sure. But you find this a lot in object-oriented programming. There are some things that solve the particular issue that you have now, but they create another issue for another instance of using these particular objects. So we'll have that discussion a lot this quarter as well. A lot of the design patterns actually still do this. They solve a generic problem, but there are still future potential problems that come up while using the design pattern, which makes you need to think really critically about the use of your design patterns. They're not one-stop fixes for problems. You have to think about when to apply them and when not. I actually have an example of what I want to show people. There's heck, I can do it now because why not? There is a site that it's actually a GitHub project. Do we know the FizzBuzz? Have I gone over this in this class? I've gone over it in some other classes, but do we know the FizzBuzz problem? FizzBuzz is a simple program where we input an integer and we want to figure out, is that integer divisible by 3, divisible by 5, both, or neither? So if it's divisible, I will call mod 3 and 5 is 0. Then we want to output the string FizzBuzz. If it's only divisible by 3, then we want to output fizz. If it's only divisible by 5, we want to output buzz. And if it's none of the above, then we want to output the same integer that was passed in numerical form. So you pass in 7, for instance, not divisible by 3 or 5, the output should be 7.
This is one example, just found it.
So how complicated do you think, if I asked you to do this, approximately how many lines of code do you think it would take for you to implement this?
I would use, you know.
In a functional language like Haskell or OCaml, this is probably 4 lines. In a more verbose procedural language like Java, you could probably write this in 7 lines, 7, 8 lines. In a very strictly procedural language like C, it might take you 8 or 9. But the idea is this is a relatively simple concept. Relatively simple. Let me find very quickly FizzBuzz Enterprise Edition. It is a beautiful piece of work.
It would be like gigabytes.
All right, so FizzBuzz Enterprise Edition is exactly applying every single design pattern to this small problem that does not need any of this extra design pattern work. So you can misuse and apply every concept for the rest of this class to create horribly bloated, disgusting code. So that, like I said, this is not a one-stop fix. I'm not teaching you something that you should always apply. It's something that you need to think critically about whether or not to apply, because if you misuse it, you can end up with this, which is so disgusting, it's beautiful. It's like looped around from so disgusting. We've reached such a negative integer that we've looped around to something. It's like, this is a work of art.
Calling it Enterprise Edition is so fun.
Yes. So if we look at the SRC, this is the source folder. If we look at the actual classes and we look at, so these are the implementations and these are just the interfaces. So all of the implemented classes, we have all of the factories, we'll talk about the factory pattern, everything in loop. So there's the loop condition, the loop context, the loop finalizer, the loop initializer, the loop runner, and the loop step classes. The parameters. Default FizzBuzz upper limit parameter has its own class. The visitors, that's another design pattern we'll go over. There's the FizzBuzz output generation context and the FizzBuzz output generation context visitor. So this is so beautiful. Arithmetics. Integer divider is its own class. Number is multiple of another number. Verifier is another class. It's so beautiful. You can, and all of this is perfect execution of design patterns. So again, I cannot repeat this enough, not a one-stop solution, but they can make your life easier. They can also make your life harder. So you need to be able to figure out when to appropriately apply them, or you end up with the worst disgusting code imaginable. Things you should know and things you should learn how to not misuse. I urge you on your own time, just Google FizzBuzz Enterprise Edition and actually go through the code of this project and look at just how disgusting it is, but how much it looks like production code. This looks like the kind of production code that you would expect for a large scale project. The issue is it's freaking FizzBuzz.
How many collaborators are on this?
There are actually plenty of forks. People have taken this and tried to bloat it up even more. So
FizzBuzz open source.
yeah, there are 443 issues that have been identified with this. It's FizzBuzz. Anyone in programming 1 should be able to write a working FizzBuzz.
Not like that.
It's beautiful. So there are 755 forks because this is just so popular. Such a good idea, such a bad idea. People love this. I use it to just talk about, we teach you some things about what exists out there, what can help you solve problems, but you can't replace critical thinking. You can't replace knowing when to use something and when not.
Your GitHub commit history doesn't show what you committed to, just as on green or not,
Yeah.
it might be all business.
All right, we had our fun for the day.
On one hand, like if you turn that in as an assignment, it'd be extremely funny fun.
Oh, yeah.
Plagiarism.
It's so much work. It is so much work to be able to produce that, and it is so wrong.
210, simple physics, like, all right, professor, here's my assignment. Here it is.
All right. We only have a couple minutes left, but the next one is data clumps. So you have different parts in your code have identical groups of variables from some other location. They could have been passed in, they could have been, so you can imagine this is something like parameters for connecting to a database. You always need the same few things whenever you connect to a database. This might lead you to copy and paste a lot of code. In a bunch of different places in your code, you're trying to connect to a database. So you need to pull the associated information to connect to the database from one central place. But there are a bunch of different places in your code where you may want to connect to that database, which means that you're always pulling the same information from the same places in the same way in different places in your code. So things you can do about this. Move them to their own object. Have a database connector object that has fields for everything you need to be able to connect to a database. And that way, all you have to do is make a new database connection object and then pass that object onto your database connection. It's way easier than trying to figure out where are these 4 or 5 things. They all come from different classes and different places. Make it an object and then have your code make one of those objects whenever you're ready, and you can automate the process of making one of those objects so that it's not a ton of work on the end user's part. And that way you only have one thing that you need to send to the database connector. And it will be able to parse that rather than sending all of those things separately. You get some benefits from doing this. I'll start, as we go through this, I start using this format a lot more. So the benefits of this is it reduces the code size, which is always a good thing. If it does exactly the same thing, less code is better. Increases code clarity. Given that you have 2 pieces of code and they do the same thing, the one that is clearer is going to be better. The one that is more organized is going to be better. So if you always have an object for this, there are fewer places things can go wrong. It looks, when you pass a database object, a database connector object, it's obvious what's happening. When you pass it a tuple of 4 objects or 4 elements of objects, who knows what that is? Who knows what it's doing? If you pass it an object that has a name, you get clarity, you get organization, your code is much easier to read. One thing to beware, if you pass a whole object as the parameter of a method rather than just passing its values, you can start creating, we'll talk about coupling, but you can start to couple your objects together, where if you change how that object is passed, if there's an extra parameter that's added, you need to change that in 2 different classes. You need to remember that there's a dependency between these 2 classes, which means there's multiple places you need to change your code when you do this. So that's a big caution sign when you are refactoring data clumps. All right, we are technically out of time. We'll come back to this tomorrow and Thursday. We'll get through as many of these as we can before we take an exam on Friday. And remember, the exam only has to do with unit testing. Nothing that we're going over this week is going to be on the exam.
Thank you.
Thank you.
When were your,
Office hours are a couple hours before class, and I can also walk up to my office and handle things after class as well. So if you have any questions or anything I can help with, I am available.
thank you, what's the reason?
I'm in 334, so it's,
Yeah,
where is that? Right above us?
I did.
No, I thought the other side of the building. I'm in between Dr. Yasmin and Doug and Tony Espinosa. And it's in the maze of offices. Okay. Sure.
I had a,